Hello out there and welcome back to the RostyMaths channel and welcome back to my year 9 series. Now, based on the data that I've been gathering, it looks like a lot of year 11s would like to be doing some work. So these year 9 videos that I'm doing, they are important for year 11s as well. So please make sure that if you're a year 11 student watching this, note everything down, really important. Anyway, if you are new here, I have stuff that's coming out literally out of my ears every day. So please make sure you subscribe below and hit that notification bell so you do not miss another upload. Anyway, in tonight's video, we are going to be looking at problems with bounds. These cause a lot of problems indeed. But before you go and watch that video, please make sure you click on the pop-out banner up there and go and watch my other 2 videos I've done on upper and lower bounds. They are the key to understanding today's video. So without any further ado, let's go and do some problems with bounds. Nice. Let's do some problems with bounds. Yes, for some people they do cause a lot of problems, but we're going to do some problem with bounds. And for now, we're going to start with this rectangle I have got here. Let's put some measurements on it. Nice. Now we got some measurements on. We're going to go and find the perimeter. Now, I'm just going to call it P. And for the perimeter, we're going to find the upper and lower bounds. So I'm going to call it perimeter max, and I'm going to call it perimeter min for the lower bound, the maximum perimeter and the lowest perimeter that we can find. Let's put some meat on the bones here. So this length, I'm going to say, has been rounded to the nearest meter. This width has been rounded to the nearest 1 decimal place. Okay, so we got 1 decimal place and the nearest meter here. Now, before I start putting upper and lower bounds on here, you must go and watch my first video on upper and lower bounds, because what I'm about to say may not make sense to you. Okay, so because I'm not going to sugarcoat it, I'm just going to go for it. So if I want the maximum perimeter and the minimum perimeter, I will need the upper and lower bound of my length. Now, since my length has been rounded to the nearest meter, then the upper bound is 14.5 and the lower bound is 13.5. Okay, so I'm going to put the lower bound there and the upper bound here. And then I'm going to do the same thing with my width. Since it's been rounded to 1 decimal place, then the upper bound is 10.55. and that's upper bound, and then my lower bound will be 10.45, and that's my lower bound there. Now here comes the first lesson. If I want to find my maximum perimeter, you know that perimeter means I'm going to add all the sides. If I want to find my maximum perimeter, I need to only add my upper bounds together. So I need to add up all of my upper bounds. Obviously, if you want the biggest possible number and you're adding, you need to add a bunch of big numbers. So my upper bound would be 2 times the upper bound of the length, 14.5, add to the upper bound of the width, 10.55, and then I will just double that, and that's going to be 50.1 meters, and that's the upper bound. Obviously, if I want the lower bound or the perimeter minimum, then I need to add all the smallest possible numbers together. So that's going to be 2 times, what's the lower bound? 13.5, and I'm going to add the lower bound of my width there, which is going to give us a tidy sum of 47.9. So check the difference out, right? That's pretty cool. All right, so that's the perimeter done. Let's go now and deal with the area. So for the area, we know that is length times width of my rectangle. And hopefully you are learning what I'm trying to teach you here, because I'm teaching you that if you are adding and you want the upper bound, you need to add the biggest possible numbers. If you want to multiply, and again, you want the upper bound, so I'm going to do this in a different color. So the area max will be multiply the upper bound times the upper bound. If you multiply the biggest numbers, you get the biggest answer. And if you want the minimum, then you multiply the lower bound times the lower bound. You can see where I'm going with this. So let's go and find the area max and the area min. So then our area max is going to be, you take the upper bound for the length, which is going to be 14.5, and you multiply by the maximum width, which is 10.55. So that's 10.55. And then just quickly multiply those together, which will then give us 152.975. We do the same thing for the area min. Okay, so you take your two lower bounds again, that's going to be 13.5, and we multiply by 10.45. Let's see what that gives us. So that gives us 141.075. And that's how you sort your problems out if you are multiplying or if you are adding. I didn't do anything on subtracting, but you can pretty much guess what will happen here. I'm just going to write it down, but I'm not going to do any questions on it because I've got a different plan for the second part. I'm focusing on things that come up a lot. If I want to find the max, let's not call it P max before I confuse someone. So I'm going to say that I'm subtracting. And if I'm subtracting and I want the biggest possible answer I can get, then I need the biggest possible number, upper bound, take away the smallest possible number, which is my lower bound. So this is going to be for the maximum for subtracting. If I want the subtracting minimum value or the minimum answer, again, I'm going to now go for the lower bound. I want the smallest possible number I can get, and I want to take away the biggest possible number from it to get the smallest possible answer. Okay, and so that's really pretty much straightforward. Now to finish up the video, I'm going to stick with my rectangle here, and I've made some changes to it. So I've basically said that the area is given to you, and the area is 490 meters, and I'm going to say it's been rounded to the nearest 10 meters. Okay, so the nearest 10 meters it's been rounded to. And then the length is going to be 15.5 meters, and that's been rounded to the nearest one decimal place. So I'm just going to put 1 dp in there. Okay, so what I want to find out here is what is the maximum or minimum width of this rectangle. So I've called it X. So I'm going to go X. Now you know that to find the width of the rectangle, you're going to do the area divided by the length. You already know that. But here comes the new learning that we're going to work out. If I want the maximum possible width, I will need the area to be in its maximum state, and I need to divide by a length that's in its minimum state. So think about it in this way. If I have, let's just say 10 oranges, okay, and I want to share that 10 oranges, what will be better, sharing it with 5 people or sharing it with 2 people? Obviously sharing it with 2 people, amongst 2 people I should say, because if the number at the bottom is really small, then I get more oranges. But the bigger this number become, if I'm sharing it with 5 people, I get less oranges, if you get the idea. So it's exactly the same here. If I want to maximize the width, I need the biggest area divided by the smallest length. And for that now, I'm going to need to do my upper and lower bound. So let's get that done. So let's work out the maximum area there. So the maximum area is 495 if I round it. If obviously I find the upper bound, and then the lower bound would be 485 in that sense. And then same thing for the length now. So the upper bound on my length is going to be 15.55 and the lower bound is going to be 15.45 there. All right, that's fantastic. So let's go and put this into practice. And obviously, if you think that you might have a different idea on how to do this, comments are always welcome down in the section below. But my maximum area is 495. That's my upper bound, divided by my minimum length, which is 15.45. And then that is going to give us, that's going to give us 32.03. And I am rounding this, believe that. So there we go, causing more problems there. All right, cool. Let's go now and do the minimum width. So, and let's have that same orange story again. So if I really want to minimize my oranges, then what I then want is the smallest possible amount of oranges, and I want to share it with the largest amount of people. So I need to have the small number at the top and a big number at the bottom. So now to get my minimum, I'm going to need my area min, smallest number, divided by my length max. I need the biggest number at the bottom. So my minimum area is 485 there, and the biggest possible length is 15.55 here. Let's see what that gives us. So this gives us a grand total of 31.2. Let me put it to two decimal places, 19 meters there. And that brings us to the end of this. So obviously, let's get the comments all lit up and see what's happening. Do you think I might have done something wrong? Do you think you might have a different way of looking at this? But this is pretty much done. Probably not the best example to use there. However, look out for other things like when you have to do square roots of numbers and you want to maximize your square root and minimize your square roots. Look out for when you have to have powers on your numbers. So like if I have a number square or cubed or whatever, and I need to find the maximum or minimum or upper or lower bound to say keep the same language. Look out for those, because remember that to square root, if you think of your square numbers and things like that, maximum will give you maximum square root, minimum will give you minimum square root. If you're squaring numbers, same sort of thing. Questions like these come up quite a lot, so look out for them. Anyway, that's the end of this video. If you like this video, give it a thumbs up. Please don't forget to subscribe below and hit that notification bell so you do not miss an upload.